This is a Friday Shoes production. This is lesson 3-6 in our book on page 167, and our target is I can solve problems using the Pythagorean Theorem. Well, let's remember, using the Pythagorean Theorem means you have to understand the Pythagorean Theorem. And what that states is, in any right triangle, if you take the shorter sides, the legs, and you take the value of how long they are, you square them, we'll call them A and B, and you add them together, they will equal the square of the longer side, known as the hypotenuse. So the sum of the squares should equal the square of the hypotenuse. A squared plus B squared equals C squared. Let's look how we can use it in the real world. Look at this parasailing situation. It says find the height of the parasailer above the surface of the water. Well, gosh, I hope you notice that they actually have a right triangle built there. And we do know the hypotenuse. We don't know one of the legs. We do know the other. It's 135 feet. So if we know two of those values, we can find the third value using the Pythagorean Theorem. Let's look at the math behind it. Step one is actually writing down the Pythagorean Theorem. They write down C squared equals A squared plus B squared. Then you plug in what you know, which is your C, which is 200, and your B, which is 135 squared, or 135, and then you square it. Square both those. You have 40,000 and 18,225. Then we isolate the variable by getting rid of this 18,225. So we subtract 18,225 from both sides. We have A squared is equal to 21,775. We unsquare that, which means we take the square root. Remember now, square rooting and squaring are inverse operations. That's why the A is left over. And of course, we take the square root of 21,775. That's a plus minus value of 148 approximately. And since we're talking about distance here, how far away something is, we're going to use the positive value because distance is always positive. So from the water to the parasailer, it's roughly 148 feet. Real world example. How about you give a shot on one of these right here? Write an equation that can be used to find the distance between the planes, then solve round to the nearest tenth. Notice we have two airplanes, and then they're separated by a distance we don't know, which just happens to be the C value on our Pythagorean Theorem. And they give us the legs. The legs always are connected by the right angle. So we'll call this one A, and we'll call this one B. And we'll put down our Pythagorean Theorem, A squared plus B squared equals C squared. Plug in what you have. We have A, which is 7. We'll square that. B, which is 10. We'll square that. And then we have C squared, which we're looking for C. How far away the planes are. Well, 7 squared is 49. 10 squared is 100. We still don't have anything to do over here. 49 plus 100 is 149. We have C squared is equal to 149. So what number times itself equals 149? Well, to figure that out, we have to undo the squaring. Again, square root cancels out our squaring. So we have an approximation here, since 140 is not a perfect square. But we get C on the right side, and the square root of 149, if I recall correctly on my calculator, when I calculate it out, rounded to the nearest tenth is 12.2 approximately. So we're talking about 12.2 miles. That would be the answer. That's how far away those two planes are. All right, let's move on there. Take a look at this one. It's a little bit more advanced, but nothing we can't figure out, especially if we can piece this together using the Pythagorean Theorem. All right, a circular lawn sprinkler with a range of 25 feet is placed 20 feet from the edge of a lawn. Find the length of the section of the lawn's edge that is within the range of the sprinkler. Well, first of all, where's that lawn edge? They're talking about this right here. And if you notice, we've got this lawn sprinkler right there in the middle, spraying water all over. And it can reach out to this area. It keeps going around and around and around. What they're asking is how much of this edge gets watered. So how far is it basically from here to there? Well, let me pull this stuff out of here. Notice we do have a right triangle built here. And on one side, they have 20 feet. That's one of the legs. We'll call that one A. And then notice on the right side, we have 25 feet, and that's called your C. We're missing this piece right here. We'll call that B, but it's the value X in their example here. And we need to have double that to figure out how much is actually covered. So step one is finding this piece right here. Let's take a look at the math. Now I've actually put this all together and redrawn the picture down here. Notice how they start out with writing the Pythagorean Theorem. Then they plug the values in that they know. You have 20 and 25, so they're putting those in their correct values. We're missing this piece. This is actually one of the legs. It's called X, and that's why they're using X over here. So we do the same thing we've always done. We square. We got 400. We square the hypotenuse, which is 625. Then we're going to isolate the variable, get X by itself. So we have to get rid of this 400 by subtracting 400 on both sides. You end up with 225 on the right side. X is left over on the left side. And then you unsquare that by square rooting. So X is equal to the square root of 225, which is 15 or negative 15. Since we're talking about a distance and measurement, we're actually going to use the 15. So take a look. Oop. Take a look at, I thought I had something here that would show up. I guess not. There it is. So we have 15 for this value right here. That's what we just calculated. So we have 15 there, but then we have two of those 15s. We have two of those triangles basically. So we have 15 plus 15. So the answer will be 30. That's how much edge gets sprinkled. All right. You try it on your own here with this example. It says, check your progress. If the rise of the stairs that are pictured here to the right of a building is 5 feet and the run is 12 feet, how long is it from point A to point B? We call this the rise right here, and we'll call this the run. Notice that makes a right triangle. So, and since the right angle is made up of those two numbers, those are your legs. So your leg is A and B, which are 5 and 12. And we're missing C. That's what we're actually looking for. From point A to point B, we're looking from here to here. From point A to B. So what is that? We'll call that C. That's our missing piece. Step one, write down our A squared plus B squared equals C squared. Plug in what we do know. We do know A. It's 12. 12 squared plus B. What's B? 5 squared. There it is. And we have C squared. Now let's take 12 squared. That's 144. I actually calculated. 5 squared is 25. C squared sits around for a while until we get the adding of this done. Here we got 169 there. I can add that in my head. And then we have to unsquare this. So we unsquare both sides. And if you remember, 169 is actually a perfect square. It is 13 exactly. And C squared, these cancel, and you're left with C. So the distance right here from A to B, which is represented by the hypotenuse, is 13 feet. Remember, we can watch this video again to get a better understanding, or read the examples in the book, or you can click on a couple personal tutor videos on the online textbook. And as usual, this is always a Wonderful Friday Shoes production.